Good day, my angels. Lesson 5. Ooh, this one had some teeth. There were some neat ones. So let's dive on in. Number 1 says find R total, then I total, and all the voltages and currents. In other words, solve it. The only thing they didn't ask me to find was the wattage in each resistor, the power use, but I could do that pretty trivially afterwards. Okay, so step 1, label downhill. Step 2, try and find total current. Don't know it. In fact, I don't see current anywhere. Step 3, look for two things. Nope. I'm going to have to rewrite this. So these two are in parallel. I'm going to combine them. I'm going to go 1 over R parallel is 1 over 15 plus 1 over 10. Using my trusty reciprocal button, 15 reciprocal plus 10 reciprocal equals reciprocal. That's a 6 ohm resistor. So I can think of this circuit as a 120 volt source, a 6 ohm resistor, and a 24 ohm resistor. And these are in series, so I can tell you that our total is going to be 24 plus 6, 30 ohms. And I can tell you that I total is going to be V total over R total, which is going to be, I can do this one in my head. I think it's going to be 4 amps. Now that I have I total, the question's going to fall apart. So here's what that means. It means that there's 4 amps going through here, 4 amps going through here. It means there's 4 amps going through here. It doesn't mean there's 4 amps going through each of these. It's splitting up, and I could be clever and use ratios, but I'm not going to worry about it because I can tell you the voltage here. If I go I times R, it's going to be 4 times 24, which is definitely 96 volts. And now I'm going to ski. Start with 120 volts, whee, and then use up 96 volts. How many volts must I use in this particular branch? 120 minus 96, or 24 volts. Knock, knock. I know 2 things, so I know 3 things. I can tell you the current is going to be V over R, 24 divided by 15, 1.6 amps. Now, if 1.6 amps went this way, I could either say, hey, 2.4 amps must have gone that way because I have 4 amps coming in, or I could have said, well, you know what? From here to here is 24 volts. From here to here must also be 25 volts for 24 volts because we started and ended at the same location. So it's going to be 24 volts. It wants all voltages and currents. Check, check, check. And now if I wanted to find the power, V times I, V times I, V times I, or I squared R, I squared R, I squared R, or V squared over R, V squared over R, V squared over R. Well, that was fun. If I haven't mentioned it already, and I think I have, I love solving circuits. Ooh, cool. Number 2. Yeah, I'm going to have to rewrite this, I think. So, first thing I'm going to realize is that these two are in series, and so I don't see a 20... Oh, sorry. Step 1, label downhill. Step 2, look for total current, don't know it. Step 3, look for 2 things, don't see it. Step 4, ski, doesn't help. Okay, step 5, rewrite. These two are in series, and so I don't see a 20 and a 10. I see a 30 ohm resistor. So I'm going to go 1 over R parallel is 1 over 15 plus 1 over 10 plus 1 over 30. I'll write 20 plus 10 just so people can figure out what my reasoning was. But I'm going to type 30, so it's going to be 15 reciprocal plus 10 reciprocal plus 30 reciprocal. And, ooh, this will work out nice. It's going to be 5. So this whole mess here is a single 5 ohm resistor. So I can rewrite this circuit as 120 volts, 5 ohms, 15 ohms. This blue circuit is the mathematical equivalent of that. And now I can tell you that our total is 20 ohms. By the way, some built-in error checks. If I go back to number 1, anytime I'm combining resistors in parallel, our parallel will be smaller than the smallest resistor in the original circuit. So 15, 10, I know the answer is less than 10. 15, 10, 30, I know the answer is less than 10 for our parallel, which it was. I forgot to write down our parallel. I should have written down our parallel equals 5 ohms. Did I write it down up here? Our parallel equals 6 ohms. They did ask me to find our parallel, so our total. I total is going to be 120 over 20, 6 amps. This question's going to fall apart now that I know I total. That means that there is 6 amps leaving right here, 6 amps going through here, 6 amps going through here, 6 amps going through here, because the total current goes through there, but the current splits up among those 3. But, knock, knock, I know 2 things. I know that the 15 ohm resistor, if I go I times R, is going to be 6 times 15. It's going to be 90 volts, which means up here is 90 volts. Now, I started with 120. That means this branch better use up 30 volts. Each of these is this branch, so this must be 30 volts. This must be 30 volts. These two will add to 30 volts, but I'll come back to that. I know 2 things. I can tell you current. Current is going to be V over R. This must be 2 amps. V over R, this must be 3 amps. Well, I have 6 amps coming in. 2 amps went this way. 3 amps went this way. This must be 1 amp, 1 amp, I times R, 20 volts, I times R, 10 volts. And there's my 30 volts that I was saying that that branch had to add to. These are so much fun, Mr. Dueck. Oh, yes, they are. Number 3. It just wants me to find the current, and I can quit. Okay. Let's see. Step 1, label downhill. Step 2, total current, don't know it. Step 3, look for 2 things, R and none. Step 4, ski, nope. You know what, I'm going to have to rewrite this. So I'm going to find 1 over R parallel. These 2 are in parallel. So it's going to be 1 over 12 plus 1 over 6. I'm able to do that in my head. That's 1 over 12 plus 2 over 12. It's going to be 3 over 12. I think it's going to be, first of all, I shouldn't put an equal sign because this isn't finding our parallel. Our parallel is the reciprocal of this. So I always write an arrow and then write our parallel equals. I think it's going to be 4. 12 reciprocal plus 6 reciprocal equals reciprocal. Yeah. So this circuit is really the same as a 50 volt source, an 18 ohm resistor, a 4 ohm resistor, and a 3 ohm resistor, which means our total is 18 plus 4 plus 3, 25 ohms. V total, no, not V total. V total is 50. I total is going to be 50 over 25. I can do that in my head. 2 amps. I usually put boxes around stuff. So 2 amps going through there also means 2 amps going through there. 2 amps are going through there also means 2 amps are going through there, which means knock knock. I know two things. This has to be 36 volts. Knock knock. I know two things. This has to be 6. What did I write? A 3. 6 volts. I started with 50. I used up 36. I used up 6. If I ski the outer ski run, this one, then 50 minus 36 minus 6, what's left here? I think 8 volts. And now I can tell you the current. I is going to be V over R. In that resistor, it's 8 over 6, which is 1.333333 amps. There you go. Oh, yep, there's the answer. 1.3 amps. 1.3 repeating. Well, that was fun. Let's do some more. Ooh, find the total resistance. Okay. Let's see if I can kind of cut some corners here. So, these two are in parallel. So if I go 1 over 2 plus 1 over 2, and then I take the reciprocal of that, I can do that in my head. A half plus a half is 1. This is the same as a 1 ohm resistor. These two are in parallel. If I go 1 over 20 plus 1 over 5, reciprocal, four. So, this thing is really a 4 ohm and a 1 ohm and a 16 ohm and a 4 ohm. Well, that's the same as a 5 ohm and a 20 ohm. So 1 over 5 plus 1 over 20 hey. Our total equals 4 ohms. That's the mathematical equivalent. Number 5 is drawn weird. And the reason it's drawn weird is the battery's in the middle, and I'm not used to that. So if you want to, you could redraw it if you felt you needed to. If you redraw it, it would look like this. There's a 20-volt battery. It hits a 2 ohm resistor. And then I'm going to draw the left-hand side, but I'm going to go to the right. Looks like we hit a 3 ohm resistor and a 5 ohm resistor if we go through that 3. And that takes us back to the battery. Sorry, I've drawn this badly. Let's try that again. Here we have a 3 ohm resistor. Well, first of all, I'm not going to draw that 3 and that 5. Those two are in series. I'm going to draw it as an 8 ohm resistor. I should have done that. And then on the right, we have a 6 ohm resistor. This is already a slightly easier version of what they gave me. Okay? The 20, everything goes through the 2 ohm, and then we split. Some go through 8, some go through 6, some go through 8, some go through 6. And now, these are in parallel, so I can go 1 over R parallel equals 1 over 8 plus 1 over 6. R parallel ends up being 8 reciprocal plus 6 reciprocal. Take the reciprocal of that. Yuck. 3.428. I'm going to carry a bunch of extra sig figs. So I'm going to go 3.42857. So that's what these two are like. So now I can redraw this one more time. It looks like this is the same as 20 volt battery, a 2 ohm resistor, and then those two are a 3.42857 ohm resistor. Oh, now I can go again. Our total is going to be 2 plus 3.42857. I'm going to use my answer button. 5.42857. I total is going to be 20 divided by 5.42857. 20 divided by answer button. And I get 3.68421. Is that what I said? 3.68421 amps. This question's going to fall apart. So that means that I have 3.68421 amps going through there. You know what? I think what I'll do is I'll label this drawing. So this is going to be 3.68. Let's go blue, Mr. Dueck, because you got red right above there. Come on. I equals 3.68421 amps, because this also must have 3.68421 amps. V is going to be I times R, so this times 3.42857. And that gives me a voltage right here of 12.63, which gives me a voltage in each of the, you know what, that is going to be the voltage. It means that that voltage is going to also be the voltage loss in the 6 ohm and in the 8 ohm. Each of those is going to be 12.63 volts. 12.63 volts. Oh, cool. Number 6, find the battery. Okay. You know what? I don't think I need to redraw this, because they gave me 2 things. Step 1, label downhill. Here's my key. I know 2 things, I and R, so I know that this has to be 75 volts. How does that help? Well, these two are in series, and so I don't see a 10 ohm and a 5 ohm. I see a single 15 ohm resistor, so I can tell you that the current running through that is going to be 75 volts, because from here to here is 75, so from here to here is 75 volts, divided by 15 ohms. which is, works out evenly. I should have done that in my head. 5 amps. So this is 5 amps, and this is 5 amps. Ooh, I have 3 amps going this way, 5 amps going this way. This must be 8 amps. And now I can tell you the voltage. This must be 160 volts. And now if I ski 160, and I could, you know what? I'm not going to go down that one because I didn't fill all of them in. 160, 75, that got me to the bottom. So V total has to be 160 plus 75, which is 235 volts. Woohoo! Yes, it is. We've come a long way. We can solve some pretty challenging questions. Ooh, number 7. Ooh, I don't need to rewrite it. How did you figure that out so fast, Mr. Dueck? Because they gave me 2 things. This is a pretty challenging question. This is probably tougher than I would feel comfortable asking on a test. Again, they want me to find the battery, so downhill, 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 downhill. That's downhill, that's downhill, that's downhill, that's downhill, that's downhill. And they told me 3 amps goes through there. That means that's 18 volts. If from here to here is 18 volts, from here to here also has to be 18 volts. Now this is 2 different resistors, but they're in series. So I can figure out the current. It's going to be the voltage, which I know is 18, divided by 12. Treat those as one resistor. Which means this branch here has 1.5 amps. Now, if 3 amps went this way and 1.5 amps went this way, this has to be 4.5 amps. Ooh, and which also makes this 9 volts. And if 3 amps come this way and 1.5 amps come this way and they flow into each other, this is also 4.5 amps. And I times R, also 9 volts. Ooh, I don't know the voltage from here to here, but I do know the voltage from here to here, and it's got to be the same. So the voltage from here to here is 9 plus 18 plus 9. 36 volts. So that means this has to be 36 volts. Knock, knock. I know 2 things. I can tell you the current. V over R. 7.2 amps. So I had 4.5 amps go this way, and I had 7.2 amps go this way. How many amps must have been coming in? Well, I guess 7.2 plus 4.5, this has to be 11.7 amps. I know 2 things, has to be 117 volts. And after all that, I ski. 117 volts. Whee! 36 volts. Oh, that was able to get me down to the bottom. I could ski other paths as well, but the total voltage is going to be 117 plus 36, which is 153 volt battery. Cool. Find the total current when this switch is A, open, and B, closed. I can do that. When it's open, let's do A right up here, our total is just 10 plus 5, 15 ohms. So I total is going to be V, 30 over 15. Heck, I can do that in my head, 2 amps. When it's closed, R parallel is, no, 1 over R parallel is going to be 1 over 5 plus 1 over 20. So our parallel is going to be 4, 5 reciprocal plus 20 reciprocal equals reciprocal. Yeah. And so our total is going to be, by the way, notice when I combined these two, there was a 20 and there was a 5 in the parallel. The smallest resistor was a 5. Our parallel is always smaller than the smallest resistor, making up your parallel circuit. Our total is going to be 10 plus 4, 14. So I total is going to be 30 over 14. 2.14. So when we close the switch, adding a resistor in parallel lowers overall resistance, which raises overall current. Now, on the one hand, that makes sense. If you add an extra appliance, you're going to use up the battery faster. You're going to draw more current. But it is counterintuitive that adding a resistor in parallel gives you a lower overall resistance. But it does. Ooh. Huh. Mr. Dueck, this was a little callback. Oh, this one's so easy that it's tough. First of all, what's the acceleration of the object if we ignore air resistance? Well, you know this. It's going to be 9.8. You could also go little g equals big G, big M over r squared, and you could calculate the gravitational field strength, but it is 9.8 newtons per kilogram, which equals 9.8 meters per second squared. B is interesting. What's the acceleration of the Earth? Well, forces come in pairs. So the force that the Earth exerts on the object will equal the force that the object exerts on the Earth. So force of Earth on object equals force of object on Earth. The force of the Earth on the object is pretty easy to calculate. That's going to be little mg. And that's going to be big M, mass of the Earth, A. So the acceleration that the Earth is going to, because the Earth is going to accelerate, it will experience a force. It's going to be pretty negligible, but it's going to be little m, 2 times 9.8, divided by mass of the Earth, which is 5.98 times 10 to the 24th, I think. And I get 3.28 times 10 to the negative 24. Meters per second, which is so negligible you couldn't detect it. And also, because the Earth actually isn't completely solid rock, there will be some flexing and some giving. I think the shock waves would just absorb that small acceleration. It wouldn't make it to the other side of the Earth. But it's there mathematically. We are in some way, shape, or form coming back sort of vaguely next week. I'm probably just going to keep doing the online lessons, and I'll use the school time if you make arrangements, and I suspect it's going to be like a sign-in sheet or something. You can drop in, and I can help you with homework, but I won't be doing in-class lessons per se. I'll continue to just put my stuff online like I've been doing. Okay? I miss you all very much. Take care of yourselves. Please be safe, my angels.